Do yourself a favor. Tonight, step outside and just look up. Our home galaxy, the Milky Way, is sparkling with somewhere between 100 and 400 billion stars. And we're now learning that planets are incredibly common. Current models predict there could be billions of worlds in our galaxy, orbiting their stars in the just right zone, where liquid water might exist. Statistically, the universe should be buzzing with life, a cosmic metropolis of countless civilizations. The numbers seem to demand it. And yet, when we point our instruments to the sky and listen, we hear nothing but silence. This is the heart of a profound and deeply unsettling mystery. It's called the Fermi Paradox, and it boils down to a shockingly simple question, first asked by the physicist Enrico Fermi during a casual lunch back in 1950. Where is everybody? To really feel the weight of that question, you have to understand the logic that makes our cosmic solitude so strange. In 1961, an astronomer named Frank Drake tried to formalize this feeling by creating a famous thought experiment, the Drake equation. The Drake equation isn't a formula you can solve for a definitive answer. It's more like a way to organize our ignorance. It's a series of questions. You start with the rate new stars are born, multiply that by the fraction of stars that have planets, then the fraction of those that could support life, then the fraction where life actually begins, then the fraction that develops intelligence, then the fraction that creates technology we could detect from Earth, and finally, you multiply it all by how long a talkative civilization might last. Here's the thing. You can plug in some very pessimistic numbers, assuming life and intelligence are incredibly rare. And yet, because the number of potential planets is so mind-bogglingly vast, the answer rarely comes out to just one. Depending on your assumptions, estimates can range from just us to millions of civilizations in our galaxy. Many of these worlds would be billions of years older than Earth, giving them an enormous head start. The galaxy should be filled with signals and star-faring empires, but it's not. For over 60 years, projects like SETI, the search for extraterrestrial intelligence, have been methodically scanning the heavens. They're listening for one structured, non-natural signal, a cosmic hello. The result has been an eerie, unbroken quiet. While they've detected plenty of signals from our own technology and natural cosmic sources, there has been no confirmed transmission from an alien civilization. This is the paradox laid bare, the high probability of alien life versus the total lack of evidence for it. We're faced with a contradiction that has led to dozens of proposed solutions, ranging from the lonely and humbling to the truly horrifying. The great silence might not be an absence of an answer, but an answer in itself. And as we explore the possibilities, you might just find yourself hoping we are alone after all. The first, and maybe simplest explanation is called the rare Earth hypothesis. This idea suggests that we aren't just lucky, but impossibly lucky. It proposes that for complex life to emerge, you need an improbable cocktail of very specific ingredients. It might not be enough to just have a planet in the habitable zone. Maybe you also need a large moon to stabilize your planet's tilt, a powerful magnetic field to deflect radiation, and active plate tectonics to regulate the climate over billions of years. Perhaps the specific chain of events that led to us is so astronomically rare that we are, for all practical purposes, alone. It's a lonely thought, but a straightforward one. But what if life isn't rare? What if something stops it? This brings us to a more ominous theory, the Great Filter. This hypothesis argues that somewhere on the long road from simple microbes to a galaxy-spanning civilization, there's a wall, a filter, that is almost impossible to get past. The terrifying question is, where is that filter in relation to us? Is it behind us, or is it still to come? If the filter is behind us, then we're special. We made it through. Maybe the leap from a single cell to complex animal life is the barrier, making us one of the first, if not the first, to do it. But if the Great Filter is ahead of us, the silence we hear is the sound of countless civilizations that reached our stage of development and then perished. This could be anything from self-destruction via nuclear war, irreversible climate change, or perhaps a technology we can't yet imagine. Now, let's get stranger. What if they are out there, but they're deliberately hiding from us? This is the zoo hypothesis. It suggests advanced civilizations know we're here, but they've chosen not to interfere. observing us like we might observe animals in a nature preserve. They could be waiting for us to reach a certain technological or ethical maturity before making contact. This idea turns the cosmos into a silent, one-way mirror. We are an exhibit, living our lives completely unaware of the spectator. Finally, we arrive at one of the most chilling explanations, the dark forest theory. Popularized by author Liu Cixin, this theory reframes the universe not as an empty void, but as a dark forest filled with hidden hunters. In this forest, survival is everything. Because you can never be certain of the intentions of another civilization you meet, the safest course of action is to eliminate any other life you encounter before it can eliminate you. Revealing your existence is a death sentence. In this terrifying scenario, the Great Silence isn't a mystery. It's a chorus of civilizations holding their breath, terrified to make a sound. It implies that our broadcasts into space aren't a friendly greeting, but a potentially fatal mistake. From a simple numbers problem, we spiral down into a cascade of possibilities, each more thought-provoking than the last. Are we a 1 in a trillion miracle? The first survivors of a cosmic test? An exhibit in a galactic zoo? Or are we a child shouting in a dark forest, naive to what our noise might attract? The Fermi Paradox offers no easy answers. It forces us to look in the mirror and confront our place in the cosmos. Is the silence of space a blank canvas, waiting for humanity to make its mark? Or is it a warning? The honest answer is, we just don't know. And that is the most profound and unsettling thought of all. If you want to keep exploring the biggest questions about our universe, make sure to subscribe, and let us know in the comments which solution to the Fermi Paradox you find most plausible or most terrifying.